Morning, sir. My name is Harshita. I am from Computer Science and Engineering Department. Today, my topic is about principle and applications of UV visible spectroscopy. Topic: Principle and applications of UV visible spectroscopy. Outline: Introduction to UV visible spectroscopy, Principle of UV visible spectroscopy, Beer-Lambert law, Instrumentation, Sample preparation, Qualitative analysis, Quantitative analysis, Applications in chemistry, Conclusion. Introduction to UV visible spectroscopy. UV visible spectroscopy is a technique that measures the absorbance or transmittance of UV and visible light by a sample. The wavelengths of interest typically range from 200 nanometer to 800 nanometers. This method is widely used in chemical analysis, including quantitative and qualitative assessments. Principle of UV visible spectroscopy. The principle is based on the absorption of light by molecules leading to electronic transitions. When a molecule absorbs UV or visible light, electrons are excited from a ground state to a higher energy state. The amount of light absorbed at a specific wavelength can be quantified using Beer-Lambert law. Beer-Lambert law. Beer-Lambert law relates absorbance to concentration and path length of the light through sample. The equation of Beer-Lambert law is represented as A equals to epsilon Cl, where A is absorbance, epsilon is the molar absorptivity, C is the concentration, and L is path length. This law is fundamental for quantitative analysis in UV visible spectroscopy. Instrumentation. A typical UV visible spectrophotometer consists of a light source, monochromator, sample holder, and detector. Light sources commonly used include deuterium lamps for UV and tungsten lamps for visible light. The monochromator separates light into its component wavelengths for analysis. Here we can see the image of instrumentation. Sample preparation. Samples for UV visible spectroscopy must be in a suitable solvent that does not absorb in the UV visible range. The concentration of the sample should be optimized to ensure accurate measurements within the linear range. Cuvettes made of quartz or glass are typically used for holding samples during analysis. Here we can see the flowchart of light source to electronic current. Qualitative analysis. UV visible spectroscopy can be employed to identify substances based on their absorption spectra. Different compounds exhibit distinct absorption patterns, allowing for characterization. This technique is particularly useful in determining the presence of chromophores in organic compounds. Quantitative analysis. The technique is extensively used to quantify the concentration of analytes in various solutions. By creating calibration curves from known standards, unknown concentrations can be determined with high accuracy. Applications include drug testing, environmental monitoring, and quality control in manufacturing. Applications in chemistry. In chemistry, UV visible spectroscopy is used to monitor reaction kinetics and mechanisms. It helps in characterizing transition metal complexes that exhibit distinct electronic transitions. Additionally, it is used in the analysis of dyes, pigments, and other colored substances. Conclusion. UV visible spectroscopy is a versatile analytical technique with a wide range of applications across various fields. Its principles of light absorption and quantification enable detailed analysis of chemical and biological substances. As technology advances, the capabilities and applications of this technique continue to expand, making it an indispensable tool in scientific research and biological research. This is the detailed applications of UV visible spectroscopy. Thank you.